PowerPoint presentation here that does tend to drag on, so if you guys just tell me to hurry up or start skipping slides or something. But so we're the Joint Water Commission. I don't know how many of you guys are aware of exactly what we do or how we do it, but we're a 75 million gallon a day treatment plant. And I guess I'll give you a little bit of background about the Joint Water Commission. First off, we consist of 4 partners. We have the City of Hillsborough, who is our managing agency and kind of manages and runs our facility, people-wise, HR-wise, and all that kind of stuff. Tualatin Valley Water District would be our second kind of largest user and money provider, I guess, if you will, of what we do out here. And then the City of Forest Grove and the City of Beaverton. And so they're all contributing funds to us, and we treat the water, and they are considered partners of the Joint Water Commission. Now we do provide water to City of North Plains, some water to Gaston, to Aloha. I mean, pretty much everybody west of Highway 217 we give water to one way or the other. So, like I said, 75 million gallons a day. We like to say that we're the largest conventional treatment plant in the state of Oregon. Eugene is actually, they do create more water they make more water than we do, but during the summer they have really good water off I think it's the McKenzie River, and they go to a direct filtration during the summer, so I think they can do something like 90 or 90 something million gallons a day. But for the type of treatment that we do, we're a conventional treatment plant. We're the largest in the state at 75 MSD. Yeah, so we serve over about 400,000 people here in Washington County, so a lot of people. Where do we get our water? The Tualatin River is our main source of the water, and this is a really old picture, but that is actually the Tualatin River. I don't know, year-wise, Tasty might have, but it's not very big, so that's not 75 million gallons a day. So during the summer, the Tualatin River, if you guys know where the Tualatin River is, you passed over it on the way in here, might have thought it was a big ditch or something, but it's not like a big, what you would call, river as far as some of the rivers that are out there. So during the summer, it would actually it wouldn't provide the water that we need. It would probably almost dry up if we didn't supplement it with water from both Hag Lake and Barney Reservoir. Did I already skip Hag Lake?
You went by.
Thanks. So Hag Lake is just a couple miles up the road here. If anybody's ever been out there and water skied or whatever, it's it holds 60,000 acre feet, and it's probably our main source of water during the summer, where we release water from Hag Lake into the Tualatin River, and then we pull it out at our intake, which is a big concrete building you guys passed just about a quarter mile down the road. Hag Lake does have boats and people on it and different recreational uses on there, but its main purpose is for like flood control. What we call Tualatin Valley Irrigation District operates it and tries to keep the whole valley down here from flooding with their they take water in and release water out of the lake. Barney Reservoir is another reservoir that we have up in the coastal range, and it's much smaller than Hag Lake, but it's actually 20,000 acre feet now. And again, the same concept. We release water from that during the summer into the Tualatin River, where it mixes with water coming from Hag Lake or water that's already in the river, and we pull it out at the intake. And there's no motorized boats or no type of recreation on there. You can, I guess, take a paddle boat or something out there. If you can get up there, it's behind many locked gates. And but there are certain times of the year when those gates are unlocked and open. There is fishing up there. I think it's catch and release only, but
Best way to discourage them.
So this is just a picture of it during the winter when it's full, and when it's full, it's the deepest part is about 100 feet deep, and it has an overflow. And actually, the water from Barney Reservoir, this is kind of the weird thing about Barney, is that it actually provides water to Tillamook, is where it was originally designed to. The lake itself was kind of a man-made lake that was designed to bring water this way, but if we hadn't done that, the water would all go to Tillamook, and so we have to monitor how much water is going to Tillamook, how much water is coming our way, and make sure that there's always enough water that we don't starve Tillamook of water, but then also that we don't flood them out too, so. There's just another picture during the summer. It's not overflowing. A lot of fancy pictures here. This is just a couple falls coming down the Tualatin River in Cherry Grove. I don't know how many of you are familiar with this side of the city, but Cherry Grove is a little community up in the hills here that these falls are up there. And we have a slow sand treatment plant up there as well that the city of Hillsborough runs and operates, and so these falls are on the way up to that. And then the Tualatin River, this here is our intake, the structure of the deck. You can see the traveling, these aren't the traveling screens, these are the bar screens that are, anything that comes through, and then we have 2 rotating traveling screens on the inside of the treatment plant that further filters it out, the debris that might be on the river. This is a picture of the river. I guess it says it for me. Where water enters the intake, the river's flowing this way. We have a boom here that will send any debris that's on top of the surface down the river, and then water is pulled back down this little channel to our pump station here. So this is what the pump station looks like when it's flooded and nasty. But we do have that deck you can see now is underwater here. But we have four motors down there, pumps. We have three 350 horsepower motors and one 300 horsepower motor. So all add up to just over 75 MGD, I believe, if we do the math, but we won't do that. The control room, we have operators here 24/7. They work some funny shifts, 7 on, 7 off. They work 6 12-hour shifts, and then an 8-hour shift, which gives them 80 hours in the 1 week, and then they're off for 7 days, and a whole nother shift comes in. So the operators seem to like it. It really helps, you save vacation time when you got every other week off. So, and then if you do use vacation, you get 3 weeks off because you get that week plus the next 2. So, or 1 on either side of that, I guess. Anyways, we'll see the control room when we walk around. Our flash mix, which is where the raw water is initially entering the treatment plant. We use aluminum sulfate for our coagulant, alum, and we do add pre-chlorine into the flash mix, and we also have the ability to add powder activated carbon. We prefer not to, but that's used in case of taste and odor. But that only happens very rarely. Knock on wood. And we have 7 sedimentation basins, and we'll see these. Each one of them is about 1 million gallons of water in it at any time, and we have 3 that were built originally with the older with the plant, and then the other 4 were an expansion in '95. And they're totally different styles, you'll see, and the newer ones seem to work much better.
You work better, huh?
Filters, after the set basins, the water will go to the filters, and we have 14 filters, dual media, sand and anthracite, and 10 inches of sand, 42 inches of anthracite. And we just very recently went through a whole filter re-rate study where we took our filter rating from an 8.2 gallons per minute per square foot up to 8.7 gallons per minute per square foot, which sounds pretty minimal, but when you add that up over the day of 24 hours, it made a difference of about, I think it was 5.5 million gallons a day or something like that, filtration wise. So we're looking into expanding the treatment plant, and I don't know, you guys may or may not know, have heard about the treatment plant in Wilsonville that the city of Hillsborough is going to build versus expanding on this treatment plant. So that whole study was kind of for naught, but it's been done, and we now have a higher rating. This is the filter gallery. We'll walk through that. This is under the filters, where the water's coming down, going one way or another, either into the clear well or backwashing or whichever way. For the chlorine, and we also use that for like any backwash water and stuff like that. It will pull out of pull out of the clear well. There's a diver, if you can't tell what that is, a diver going into our clear well. We have them inspect our clear well almost annually, you know, and see if there's any cracks or problems that they might find underneath there. This is our laboratory. We'll walk through that. If you guys have any questions, please feel free to shoot it out. We have 2 pump stations. Pump station 1 has 6 different motors, different pumps in it, various sizes, up to the biggest of 700 horsepower, which pumps about 6,000 gallons a minute. And we had 2 backwash pumps. Now, this was the original pump station built. This plant was originally constructed in like 1976, and it was built with 4 filters and 2 set basins, and it's just been expanded on and expanded on. And so you guys will definitely probably be able to tell some of the older stuff versus some of the newer stuff if you walk around. This is pump station 2, again put in the 95 expansion. You can see these motors are much larger. They're 1,000 horsepower motors, and they'll pump about 9,000 gallons a minute. So against the 150 PSI head, which is what the reservoirs that we have put down are, that's pretty some pretty big motors. Fern Hill reservoirs. So once the water leaves the plant, pumps it up on top of the hill, and we have these 2 reservoirs up there, and these are each one of them is 20 million gallons that it holds, and it actually provides the system pressure for Hillsboro and all those different places I was talking about. This is the highest point, provides pressure, which is actually about 150 PSI. So if once the water's entering the distribution system, they'll have a pressure reducing valve on there, PRV, to bring it down to whatever pressure they want. But we provide a lot of water to like Intel and other industrial users along that industrial user road there, we call it, and they like the pressure. But then the houses that are around the neighborhood, they don't so much. So this is inside the reservoir here, as the second one was being built. It's pretty cool, the columns and stuff in there. We do still use gas chlorine. Not a lot of plants probably still use gas chlorine, but we use so much of it, we create so much water that it's kind of a big conversion to go over to anything else. So we have 9 one-ton cylinders on site, and we will walk through that. Well, we may look through that. This many people, I don't know.
Will you in the future make a conversion?
Well, we have done studies on that, on whether what would be the best scenario for us, whether to convert over, to remain as it is. And again, when we were talking about expanding, that was going to be kind of okay, we're expanding, all these changes are going to happen, we can make that conversion if needed. But study came back as saying that we're kind of right now better off with gas, and even if we expanded to maybe just increase our holding capacity and how much we can have on site at one time. But there are, there's always the ability or the chance of switching over later on. But right now with gas chlorine, gas chlorine is pretty dangerous, and one of the big things they do is it's called a process safety management, PSM, that we have to go through, update annually, resubmit to the EPA and OSHA, and there's all kinds of different regulations that go with having the gas on site. So if we were to able to move over, those would all go away, which wouldn't be all that bad. Allen tanks, you guys will see those aren't that exciting. That's what's holding our coagulant. Caustic tanks, we use caustic, sodium hydroxide for pH adjustment. So after all the treatment, just before we pump it out, we add caustic, which alum takes down your pH, and then we bring it back up with the caustic. So we always shoot for about a 7.7 as our finished water pH.
And is that added right there at the 2 million gallon clear well?
It is. It's added. It is added in the clear well. It's added towards the end of the clear well. Okay. The clear well kind of serpentines back and forth, and on the last turn is where we add the caustic. Okay. So it has a little bit of time to kind of
just enough
before it gets pumped out. Yeah.
Okay.
Powder activated carbon. Like I said, this isn't something we enjoy doing, but in 2008, we have this onion field upstream from us. It's called Wapato, and it some pretty nasty water here that they're pumping into the river. This water sits in their little lagoon all winter long and just turns septic and nasty. And then during the spring, when the river levels get nice and low, they decide to pump it into the river for us. And it really causes havoc with our treatment process and has caused us some taste and odor problems in the past. And so with that, we purchased some new powder activated carbon feeders that fed these super sacks here weigh like, I think they were 900 pounds of carbon. And before that, back to the first plant in '76, it fed 50-pound bags of carbon, and we couldn't keep up with the increase in flow and demand that we had. So this was all put in 2008. And we haven't used it since 2008, I don't think. So again, knock on wood, but they do pump this stuff in every year, but it hasn't been to the degree that it was in 2008. So, but we're ready in case it's needed.
Do they let you know? Figure out feedback?
We are working with them pretty closely anymore, especially from there, and we had actually a new plan developed where they can only pump, they have 2 pumps and they're both pretty old, and they can only pump until the end of April 30th, which is tomorrow, and with the big pump, and then they can run the smaller pump, and it's on a float and doesn't nearly impact us the way the other one does. But yeah, we've worked pretty closely with them since 2008. So
It still does. I was gonna say, it still does give us a pretty good impact. Just a couple weeks ago, actually, river levels were low. They were pumping out of both, and within like a 2-hour swing or so, we can see like our alum demand go from 20 to 49. Just instantly, our chlorine demand goes way up just from that. But we don't have nearly the taste and odor issue. It's just it demands a lot of chemicals to treat.
And 2008 was kind of a bad year to compare to, because they had problems with they have a dike around their little pond that keeps the river out. Their dike broke, filled it up way higher than it normally gets, and so there was a lot more water than normally there is, but it's pretty nasty stuff. Oh, polymer feeder, not that exciting, but it's on there. We do feed a filter aid polymer prior to the flume taking the water to the filters. It helps with, helps whatever particles might be making it to the filters stick to the media, and we couldn't run without it. It's very helpful. Surge tanks, any water that comes from a backwash, when we clean the filters or whatever, will end up down here in the surge tanks. There's actually 2 of them, this one here obviously, and then there's kind of one that's underground over here that was installed later on. But so this is where all the wastewater goes, and then it gets slowly pumped back up to these thickeners, which we'll see, and it's probably the next slide. And that's where all the sludge and everything will settle out, and we pump the sludge out to some drying ponds, and then that water will end up getting, there's the drying ponds, and then that water gets recycled back to the flash mix, any of the clean decant water that's coming off the top. So and there's just some more settling ponds. Yeah, we make water 24 hours a day. Said that. All right. That wasn't too bad, huh?
Okay.
Questions?
How many people you employ here?
There's, I think, 17 employees total. We have like 8 operators, because there's 2 per shift, so 2 on the day shift, 2 on the night shift, and then there's 2 shifts, so 8 there. We have an electrician, we have a millwright, we have an instrument tech, we have another maintenance guy, computer guy, like what do we call him, Paul?
Systems analyst.
Systems analyst, and then me and Chuck, my
And
boss,
Chandra.
and a lab technician. Yeah, so we're 17. Kathy, a lot of people. That's 17. Thanks for the quick math. Yeah.
What is the turbidity coming into the plant?
Well, currently it's probably about 6 or 7 or something like that. I'm guessing. It's a guess, but normally it's pretty low, less than 10. During the winter, it can get up into the hundreds. In fact, I think our highest one is like 1,200 that we've documented or something like that. So that's pretty. People are a little
That's a
more
big
tense
swing.
around here at 1,200 NTU.
Yeah, but because it can change, because it's a river and it has it's a flashy source. So unlike a lake or wells, it's not always consistent.
Yeah.
Keeps things busy.
And why do you pre-chlorinate?
Well, good question. So, we used to pre-chlorinate in a lot different way than we do now. We used to pre-chlorinate like really heavy in the flash mix, and we would count the contact time through the set basin. This is part of our CT calculations that we had to figure out. You know, chlorine in the pre-chlorine causes disinfection byproducts. One year I think we had some pretty high disinfection byproducts, and then that was kind of like why are we still doing this? But it actually helps with, so at that point we cut it a lot. We don't feed near as much as we used to in the flash mix. However, we do still feed it in the flash mix because it does help, believe it or not, with like the oxidation, and helps with the coagulation. I mean, the chlorine will actually help our alum work a little bit, and it also keeps stuff from growing in our set basins. It keeps everything kind of looking a little bit nicer, you know, algae and stuff like that, but helps knock down the chlorine residual.
What's the highest level of incoming turbidity that you can actually treat?
Well, we
Treated
treated
800.
Yeah, we treated 800 quite regularly. Well, not quite regularly, but enough to, no, we don't like it. But I mean, we treated the 1200. I mean, but you know, it's no fun. I mean, we're not making the water that we would be making on a normal less than 10 kind of a day. I mean, we're doing everything we can do just to keep it running. You know, and our filters, we normally get about 80 hours per filter run.